Hello class, today we're going to be looking at speed and velocity. This is still chapter 10 section 1. We just broke it up from what we covered the day before. So comparing speed and velocity. First, speed is your rate of change in position or the rate of motion. How quickly are you changing your position? We would generally mark this as instantaneous speed or average speed or possibly constant speed. So instantaneous speed is your rate of motion at any given instant. An example would be a speedometer in a car. At that one moment, how quickly are you changing your position? Constant speed is looking at a speed that never changes. So we're looking at that you maintain the same speed over a period of time, and an example of that would be cruise control. Now, generally, if we want to look at the comparison of this, you'll be able to see it on a graph or you'll be able to see it in a data table. So to show you the difference between constant speed and changing speed, in this situation here, we change in position is 6 meters per second. This is also 6 meters per second. And this is also 6 meters per second. And here as well, 6 meters per second. So they're never changing the rate of speed. In this one, we are changing our rate of speed. So this one is 1 meter per second. This one changes by 3. This one changes by 5. And this one changes by 7 meters per second. So you can see in this one we have a varying change in speed or change in motion, and in this one it's maintaining a constant speed. When we calculate speed, we're calculating an average speed. An average speed is your total distance over your total time. Now, sometimes it will say calculate the interval speed or a moment in time, and you'll do that sometimes on worksheets or on word problems. But most of the time when we calculate speed, we are actually calculating total distance over total time. And so this will change based on if you get stuck in traffic, or maybe you slow down at a period of time, or you speed up over a period of time. You're just looking overall, how quickly did you change your rate of motion. Generally, this is measured in meters per second. It could be in things like miles per hour or kilometers per hour. You have to look back in the problem and find out what the distance was measured in and what the time was measured in to put the correct unit after the number. Make sure you put units after the number. If it's just a number, it doesn't tell me anything. It needs to be a number and the unit. If we were to take a look at a distance time graph, your distance time graph will show you the distance that is covered by an object at regular intervals of time. So distance and time, if you notice here, distance here, time here, the slope of the line in here is the speed, because distance over time is going to give you the slope. So the slope of this line on a distance time graph is speed. You definitely need to understand that and be able to read a distance time graph. You're going to have to be able to read a distance time graph versus a velocity time graph. So being able to understand what the graph is actually showing you. I would make sure you go ahead and draw this into your notes if you haven't yet. If you're listening to this for the first time and you didn't have it in class, make sure you draw this in, just to show you comparison of what's happening. This object is moving very fast. This object has a curved line, so they're accelerating. This object has a curved line downward, so it's decelerating. And this object is just going slower than the other ones. This graph over here is showing you a constant rate. The slope, or that calculation of slope, will not change on any of those points. So we're going to skip these right now. Velocity is speed and direction, and that's the key part, speed and direction. In the problem, you need to include direction. So in order to have direction in the problem, one of the key parts about the change in the equation is that we're going to use displacement instead of distance. So this one is going to be displacement over time. While it looks very similar to the same equation, it is not the same. Displacement can be a different number if you remember back to our previous notes. Displacement is a straight line path from point A to point B. That can be a very different number than the distance that was traveled. Your answers will include direction, so you have to make sure that you have that in there as well. And the units will be similar. Meters per second, kilometers per hour, or miles per hour as some examples. Now go ahead and put this velocity time graph in. A velocity time graph will show acceleration. So the slope in here shows acceleration because acceleration, we haven't done that equation yet, but acceleration is a change in velocity over time. And that's what slope is showing you. So just so you understand what the slope of a velocity time graph will show you. I would go ahead and write these in so you can see what it looks like. Acceleration is shown here on a velocity time graph. Steady speed is a straight line across. Deceleration. And then this right here is showing increasing acceleration. It's not a constant acceleration, it's showing a changing acceleration. So we want to compare distance time graphs and velocity time graphs. First, distance time graph, if we show a line that's going up, we're seeing that this is distance, so we're seeing that the car or object is driving away from point A. And so it's going, maybe if this is 0, it's going 1, 2, 3, 4, maybe 5 meters away. In this case, the object has decided to stop moving. It's staying at 5 meters. It's not moving any further than that at that point. And then here, when it comes back down, since it's distance time graph, it's taking that same path right back to point A. At this point, we are at 0 meters again, and so our displacement would actually be 0 at this point. If we compare that to a velocity time graph, when we see this starting point at, this is going to be in meters per second. If we see that starting point at 0 meters per second, when we increase our velocity, we are actually going to get to 5 meters per second. At this point, they are maintaining a constant velocity of 5 meters per second for that whole time. It's not that they're not moving, they're just maintaining their velocity. And then they'll start slowing down. So in this case, they're slowing down back to 0 meters per second, back to a stop. Okay, so make sure you can distinguish the difference between those. We will practice more of them in class, but make sure you understand that when you're looking at a graph, you need to look at what the graph is actually showing you. Is it something like velocity? Is it something like distance? Is it displacement? And make sure you're looking at the information that's given to you. Okay. That'll be the end of the notes this time, and we will start acceleration, calculating acceleration on the next set of notes.